Today we are going to discuss on the topic of electrocardiograph measurements. We can see it in the first unit itself. What is electrocardiogram? Electrocardiogram is nothing but study the pulse activity and the current pulse activity of the heart muscles. But in this we are going to discuss on the topic of how it will be measured by using an instrument. An electrocardiography is a diagnostic tool used to record the electric activity of the heart. Medical mechatronics, which combines the principles of mechanics, electronics and computer science, plays a crucial role in the development and application of ECG measurements. ECG measurements typically involve the use of electrodes placed on the patient's skin, which detect the electrical signals generated by the heart. And the signals are which can be amplified and filtered. Why? Because filtering we want to rectify the resist the unwanted signals that has to be disturbed by the patients and processed to produce a graphical representation of the heart's activity known as electrocardiogram. And also medical mechatronics technology is used to design and manufacture the hardware and software components of ECG machine, including the electrodes, amplifiers, filters, signals, processors and display system. Mechatronics also plays a vital role in the development of wearable and portable ECG devices, which can monitor the heart's activity over extended period and in a variety of settings. We can see in the block diagram in this we are getting the drive motor, which is the pen motor, and this is derived to a gear train, and in which the lead selector is placed in the patient's skin, through which we can able to get the amplified signal through an amplifier, and through the amplifier to the heart filters, and then the heart stylus will convert it to the electrocardiograph, in which we can able to draw the ECG gram, in which we can able to rectify that PQRST wave, through which we can able to identify whether the heart's activity is normal or not. And also along with that we can able to discuss the blood pressure measurement by ultrasonic method. Blood pressure measurement normally we can used by BP used by sphygmomanometer, but we are used by an ultrasonic method. Blood pressure measurement is an ultrasonic is a non-invasive technique that uses high frequency sound waves to measure the blood flow, velocity and calculate the blood pressure. Normally the human range is up to 90 to 120 mm per Hg, which is the normal blood pressure rate of a human. And also now this method is commonly known as the Doppler ultrasonic method, named after the physicist Christian Doppler, who first described the Doppler effect. The technique involves placing an ultrasonic transducer which emits a high frequency sound wave over an artery, typically in the arm or leg. The sound waves reflected off the blood cells flowing through the artery and are detected by the transducer. What is the transducer? Transducer is nothing but a type of sensor which is able to convert one form of energy into another form of energy. The frequency shift of the sound waves caused by the movement of the blood cell is proportional to the blood flow velocity. The frequency developed by the transducer must be proportional to the blood flow velocity. What we are giving to the patient must match the blood flow. That should be measured. By measuring the blood flow velocity, the ultrasonic method can calculate the systolic blood pressure. Systolic blood pressure plays a vital role while the systolic pressure is in normal condition. Thank you. In next class we can able to discuss about the plethysonograph and phonocardiography.